Okay, good morning. So we solved a question on risk and return, and I promised to send you a video on how to solve a question on it. So using the same example we solved online. So we have years from 1, 2, 3, 4. We have the different probabilities. We have the returns in percentages X, and then we have that of Y. Then the first requirement of the question is to find the returns of each stock, then the standard deviation of each stock. We'd also find the portfolio risk assuming equal weights were invested, and then the portfolio risk assuming 75% was invested in X, and the question says the rest was invested in Y, but we know that that is 25%. Right, so the first thing we look at is the return of X. So how to find the return of X? For the return of X, we have the expected return of X is equal to the summation of the probabilities times the X's. This is the formula. So you see P here. We have all the P values, that's the probabilities that we have here. And then we have the X's 1, 2, 3, 4. We'll do multiplication. We have 0.016, 0.012, 0.00, and then minus 0.08. When we sum everything up, we have 0.02, which is equals to 2%. Sorry. We do the same for Y. Same formula, just that this is Y. Then the P values multiplied by Y. Multiply and add. We get a total of 0.08, which is 8%. Now, this question did not ask us to find the return of a portfolio, but I believe it's very important. So in finding the return of the portfolio, we look for the weight of asset A, or X in this case, multiplied by the expected return of asset A, or X. So let me just write that here. So this can be X, this can be X. Then we add that to the weight of B or Y multiplied by the expected return of B or Y. The weights in the question is assumed that they were invested equally. So 0.5 for X and then 0.5 for Y. Then the expected return of X is 0.02. That's what we've calculated right here. And then the expected return of Y is 0.08. That is what we have calculated down here. Right, so when you do the math, you get 0.01 plus 0.04, giving you 0.05, which is 5%. And that 5% is the total return of the portfolio, or the expected return of the portfolio. Right, the second requirement of the question is to find the standard deviation of each stock. And in finding the standard deviation of a stock, we bear in mind that the standard deviation is equal to the square root of the variance. Therefore, the standard deviation of X, for example, it will equal to the variance of X. Now, this is the formula for finding the variance of X. We have the summation of the X's minus their expected returns all squared multiplied by their probabilities. So if you have done the demarcations, this summation, there's the X's, is the expected return of X, and there's the probabilities. So for the variance of X, we have 0.08, which is the first X value. This is the second X value, third, and then so on. And then these are the probabilities. Remember, we squared them, multiplied by these are the expected returns. Sorry, that's of X. We square them, and we are multiplied by the probabilities here. Then we get this all squared multiplied by all this. You know, it's a little bit unnecessary to do something like this in exam. Maybe after writing just this, you can point your calculator and come to the actual figures. So you see, we have 0.00072. We have this, we have that, we have this. You add all, you get the variance of X as this. And when we have the variance of X, we've already stated here that the standard deviation of X is equal to the variance of X. So So what we do is we just take the square root. Then we have 0.040987, which this could be rounded off to 0.041, or you can leave it the same, which will give you 4.09% or 4.1%. That's if you round it off. We do the same thing for y. We have 0.26. This is a deepening here. I made a mistake here. So it's 0.26. This 2 and this 6 minus 0.08, of course, which is the expected return of y. So all the y's minus the expected returns, all squared, multiplied by the probabilities. This is the formula. So you see it's the same formula up here and then here. It's just that this y, this is x, this expected return of x, this expected return of y. Probabilities are constant. Multiply this by this, do the math, then get the variance of y as this. Again, in an exam setting, not to waste time, you can just write this and then write the final answer this. And sum them up, get your variance. Take the standard deviation of, to get the standard deviation of y, we take the square root of the variance of y, what we've calculated here. It will give you 0.1084, which is 10.84%. Now, in calculating for the standard deviation, we always leave the answer in percentage. Standard deviation, remember, is a measurement of risk. So the question tells you, to calculate the standard deviation of each asset and find out which asset is more riskier. The higher the standard deviation, the more risky the asset is. So we can be able to deduce that the Y stock or Y asset is more risky because it has a higher standard deviation as compared to that of X. And let me draw your mind to something very briefly. We have a concept in finance that the higher the risk, the higher the return, the higher the risk, or higher risks are associated to higher returns. When we look at the two returns, the two risks, we see that of Y has a higher risk and that of X has a lower risk. So the risk of Y is 4.1%, but then its return is 2%. 2% here. And for the Y, the risk is 10.84% and it has a higher return of 8%. You see that higher return is attributed to higher risk, and then a relatively lower return is attributed to a relatively lower risk. Right. The next requirement of the question is for us to find the risk of the portfolio. But then before we do that, there are certain things you might not be asked to calculate, but they will help you in solving for the risk of the portfolio. And that is the correlation coefficient. You need it at the end of the formula for the risk of a portfolio. But then before we also solve for that, we need to know the covariance between X and Y to help us find the correlation between X and then Y, or A and B, like I've written here. All right. So in finding the covariance between the stocks, we have the probabilities multiplied by the X values minus the expected return of X, which multiplies the Y values minus the expected return of Y in the same year. So for year 1, see I've written 1, 2, 3, 4, year 1 to 4, the probabilities are constant. All we do is just take the first return of of X, second return of X, third, fourth, subtract all of them from their expected returns, and then whatever we get there, we are multiplying by the same Y's minus their expected returns. We come down to this here. Come down to this, we see that we have the same probabilities there. When we subtract this from this, we get 0.6. This from this will give us 0.18. This is from this 0.04 minus 0.02, and then so on. So we have 0.2 by this, 0.3 by this, 0.3 by this, 0.2 by this. Again, in an exam, it's not needed to do all this unless you have a lot of time on your side. You can just write this formula down and then write this 0.2 this 0.3 this 0.3 this 0.2 this. You don't even need to come and write this. You just have to write the answers. After multiplying this by this, the answers you get. After multiplying this by this, the answers you get. I've not written them here. You write those answers down, sum them up, and get your covariance as 0.0432. Now for covariance, you don't leave the answer in percentage, you just leave it as it is. Right. In finding the correlation coefficient between A and B, or again X and Y, it is the covariance between X and Y. So this is the correlation between X and Y is equal to the covariance between X and Y all over the standard deviation of X or A, standard deviation of Y. The reason why there's A and B here is because there are times the stock might be given to you as A and B. You understand? That's why I've written here that in this case we use X and Y since those are the stocks. So we take the covariance of A and B, or I beg your pardon, X and Y, which is 0.00432. That is this. And we take the standard deviation of X, standard deviation of Y. Please, we convert them to percentages to decimals before we use them. We don't keep them as they are percentages. So for example, here we rounded it off to 0.41. That was 4.1%. So 0.41 times 0.1084. You see we have done it here. I first multiplied this by this before I divided. So multiply this standard deviation of X by standard deviation of Y, then you divide, you get a total figure of 0.972. This in particular, the correlation coefficient, it lies between 0 and then 1. If it's closer to 0, there is a weak relationship between the two variables, and if it's closer to 1, there's a strong relationship between the two variables. So a figure of 0.972 as a correlation coefficient suggests that there's a strong relationship between X and then Y. This is not like the ratios where you need to put down a narration or anything. You can just leave your answer as this. I'm just explaining this so that you understand, and so that you know too that whatever answer you get here should not be more than 1 or less than 0. Okay, so having done this, we can move to the return of the risk. This is an error, right? So this is an error. It's rather supposed to be the risk. All right, so this is basically going to tell us, we found out how risky just one asset is, but now combining the two assets, we want to know how risky, and when we combine those assets, how risky our portfolio becomes. The formula is this: the standard deviation of X times, I deliberately wrote this in green so that it is distinguished from the X. So standard deviation of X multiplied by the weight of X all squared, plus the standard deviation of Y multiplied by the weight of Y all squared, plus 2 times the weight of X times the weight of Y, which will multiply the standard deviation of X multiplying the standard deviation of Y, and then the correlation of X and Y. I've written under here that note weights will be given. The question will obviously tell you what weights were used to invest. And I'm saying that if they are not given, you assume they are equal. That is 0.5 for asset A or X or whatever first asset, and then 0.5 for the second asset, which is X or Y, which is B or Y, sorry. Right, so when we want to put our values into the formula, we have 4.1 here as the standard deviation of X multiplied by 0.5, which is the weight of X all squared, plus the standard deviation of Y multiplied by the weight of Y all squared, plus 2 times weight of x, weight of y, multiplied by standard deviation of x, standard deviation of y, now multiplied by the correlation of x and y. You notice I've done this numbering here 1, 2, 3, 4, 5 because people could get these formulas right and then still get the final answer wrong. So you have to do everything sort of systematically. So we multiply this by this and square it as 1. That's what I've gotten here. Define the 4.205. Multiply this by this and square it. That's 2, which is this. Then now you multiply this by this, which will give you, I think, 0.25 or so. Then you multiply by 2 to give you 0.5, which is your third item here. You multiply the 2 standard deviations, 4.1, 10.84, which is 4. You get this. Then you finally come and multiply by this figure. Now you realize that this is adding this, and that is adding the 3 multiplications. So you do that one. So 4.2025 plus this plus all this in bracket. For all this, we got 21.599784. At this stage, if you can write to even 6 decimal places, it's okay, so that you don't get a final answer that is totally different from what the right answer is. So you now, after getting this 21.599784, you can add. So you add, or you're supposed to be getting 55.1786. When you take the square root of that, you get 0.743, which is equal to 7.43%. So that 7.43% becomes the risk of the portfolio. Now look here, see that in using a standard deviation of x and then that of y, we didn't convert them to decimals, we used the percentage. Our final answer will be kept in percentage, so we just use the same percentage, 10.84%. Don't go and convert it into decimal or your answer will be wrong. Okay, so the second part is, what if he invested 75% in x and the rest in y? That is 25%. Of course, when you take 75% out of 100%, we have 25%. So I'm saying all we do is change the weights in the formula for the risk of the portfolio. That is, so you see we have the same standard deviation for x, but then now the new weight of x is 0.75, and we have the same standard deviation for y, but the new weight for y is 0.25. Now the weight of x, weight of y is 0.75 times 0.25. Then we solve the rest of the formula the same way we did for the first one. You should get 32.995, which is equal to 0.0574, which is 5.74%. Now, the question also told us that we should find if his portfolio risk will reduce or increase. And initially it was 7.43, but now it is 5.74. So that's a 1.69% reduction. You realize that when he was investing equally in both x and y, his risk was high because y seems to be very, very risky. But when he now moved more to x, which is the 75%, to x, which, and we know x was less riskier, and then very little amount was invested in y, realize that the risk of the portfolio reduced. We can even say that if we assume he invested, or he decides to invest 90% in x and then 10% in y, the portfolio risk will further reduce because he's investing just little in the very risky assets and more in the less risky assets. So this is how to go about solving a question on portfolio risk and return. I'll send you the pictures as well as the videos.